Myself Mythri. I am studying second year in ECE at Shastra University. I came to know about many tools, apps and acquired knowledge about them through this internship. We worked on the project Switch Control LED with LCD using PIC microcontroller. Let's discuss tools used. MPLab X IDE. This software is used to write the embedded C program for the PIC 16F877A, and we compile it with the XE8 compiler and generate the hex file that will run inside the microcontroller. XE8 compiler, which converts the C code into machine code in hex format so that the PIC can understand and execute the instructions according to that. PIC SimLab. This is a virtual lab where the PIC 16F877A, LED, switch and LCD are simulated so that the circuit can be tested on a computer without real hardware. Now moving to the components used in this. The main component is the PIC 16F877 microcontroller. It is an 8-bit microcontroller with multiple digit inputs and output pins, built-in timers and peripherals like ADC, which makes it very popular for academic and beginner embedded system projects. In this project, the PIC 16F877A acts as the brain. It reads the input from the push button switch and controls both the LED and the LCD according to the program stored in its memory. Now we have the LED, which is used as a simple visual indicator. When the microcontroller turns the LED on or off, it immediately shows the result of the switch input and the program logic. So anyone watching can quickly understand the output status. The push button, which is connected to one of the digital input pins of the PIC, and it is used to give a binary input, either logic high or logic low, to the controller. Another important device in this project is the 16x LCD module. This display can show two lines with 16 characters on each line, so that it is very convenient to display short text messages from the microcontroller. In our project, the LCD is used to display messages such as LED on and LED off, and it helps to clearly show what the microcontroller is doing internally when the switch is pressed or released. We also use resistors and a 5-volt power supply. The resistors are mainly used for current limiting, for example, in series with the LED to protect the components from the excessive current supply. The regulated 5-volt power supplies, the PIC 16F877A, the LCD and other components, because this microcontroller is typically designed to operate at around 5 volts. Now I will explain the block diagram of our project. In the block diagram, the PIC 16F877A microcontroller is placed at the center because it is the main controller of the system. On one side, we have the push button switch, which is connected to one of the digital input pins of the PIC. On the other side, we have the LED connected to an output pin and the 16x2 LCD module, which is connected to a group of output pins from the microcontroller. The idea of this block diagram is to show how the input and output devices are linked with the controller. The switch is the input block. The PIC 16F877A is the processing block, and LED and LCD together form the output blocks. Power supply and ground connections to each block are also implied, even if they are not shown in detail, so that all components receive the required 5-volt supply and share a common reference. This block diagram makes it easy to understand the flow. The signal starts from the switch, then goes into the microcontroller, and Finally, the response is seen at the LED and on the LCD display. So, just by looking at this diagram, we can clearly see how a simple user action at the switch is processed and then converted into visual outputs in a project.
Myself Juhitha, I am studying second year ECE at Sastra University. So let's discuss working principle in this slide. Step-by-step working. In this step-by-step working, when the power is applied, the PIC16F877A microcontroller starts executing the program. The LCD is initialized first. In LCD, the LCD mode is usually 4-bit or 8-bit, which is set to these bits. Display on, cursor off commands are given. In this LCD is cleared. Switch on monitoring. This is also called polling method. The switch pin is configured as input. The microcontroller continuously checks the switch state using polling method. Inside the infinite while loop, 1 is released. Polling means the microcontroller reads the switch pin instead of waiting an interrupt. When switch is pressed, switch input becomes logic high. It means 1. When switch is low, it means it becomes 0 depending on the wiring. Microcontroller detects the pressed condition. LED turns on by making the LED pin logic high. LCD displays the message. When switch is released, switch returns to its normal state. Microcontroller detects the released condition. LED turns off by making the LED logic low. LCD displays the message. It gives continuous operation. The process repeats continuously as long as system is powered on. Any change in switch state is immediately reflected on. It checks the LED status LCD message. In this slide, we will discuss about software implementation. Steps in MPLAB XIDE. First, open MPLAB XIDE. Create new project. In this project, select standalone project. Select device. Choose the device named as PIC16F877A and select the compiler. Choose the compiler as X8 compiler and write the embedded C program. Configure trace registers. Initialize LED. Write logic to read, switch and control LED and LCD. And build the project. To build the project, compile the code. If there are no errors, a hex file is generated automatically. Hex file usage. This hex file is used for simulation in PIC SimLab or for programming the real PIC microcontroller. In this slide, we will discuss about embedded C code. In this embedded C code, trace register configuration is involved. Trace registers define whether a pin is input or output. In this switch pin acts as input, trace X is equals to 1, it acts as input. LED pin, it acts as output. Trace X is equals to 0. LCD pins is also acts as outputs. In this LCD pins, RS, EN, D4 to D7 pins are set as outputs. This configuration ensures switch can send input to PIC. LED and LCD can receive output from PIC. In this, many loops are involved, such as infinite loop. While one loop returns continuously, inside the loop, switch state is checked repeatedly. Decision is made using if-else conditions. There are many conditional statements. If switch is pressed, LCD will on and LCD shows LED on. Else LED off, LCD shows LED off. This logic ensures real-time response. Simulation using PIC SimLab concept. In this components are used such as PIC16F877A, LED 16x LCD. Thank you.
Myself Ashwini, I am from third year ECE LPU University. Now I am going to discuss about simulation using PIC SimLab. PIC SimLab is a virtual simulation tool used to test microcontroller projects without using real hardware. It is very helpful for students to understand how embedded systems work. Steps in PIC SimLab simulation are: first, we open the PIC SimLab software on the computer. It provides a virtual environment where we can simulate electronic circuits. Then we choose the PIC16F877A microcontroller board from the available options. This microcontroller is widely used in embedded system projects because it has multiple input-output ports and supports like LCD, ADC, timers, etc. After selecting the board, we connect the components virtually. LED connected to a port pin, for example port B. Switch connected to another port pin used as input. LCD connected using data and controlled pins. Then load hex file. The program for this project is written in MPLAB, embedded C or assembly, compiled and converted into a hex file. This hex file is then loaded into PIC SimLab, so the microcontroller knows what program to execute. After loading the hex file, we start the simulation. Now the virtual circuit behaves like a real hardware circuit. Now in this slide I am going to discuss about simulation output. When the switch is pressed, the microcontroller detects input as high. The LED turns on. The LCD displays LED on. When the switch is released, the microcontroller detects input as low. The LED turns off. The LCD displays LED off. This behavior confirms that input device is working. Output devices LED and LCD are working. Program logic is correct. Microcontroller is functioning properly. This proves successful implementation of the embedded system project. There are many applications in this project like home automation system, industrial control panels, embedded consumers, and basic IoT systems. This concept is used in smart homes. For example, pressing a switch can turn on or off lights, displaying appliance status on LCD, controlling fans, doors, and security systems. In industries, machines are controlled using switches and sensors. Status of machines can be shown on display. Operators can monitor on-off conditions. Safety systems can be implemented using similar logic. Many daily use devices work on the same principle, like washing machines, microwave ovens, air conditioners, remote controlled devices, etc. They use microcontrollers to take input and control output devices. This project is a foundation for IoT, Internet of Things. Button input can be replaced with sensors. LED can be replaced with small appliances. Data can be sent to mobile apps or cloud platforms.
Myself Aishwarya, I'm a second year ECE student at Sastra University. So let's start with a demo of the simulation. So if you see the file, we have the loadx, where you can load the file from the MPLAB X IDE. And let's go to help. In that we have the file which is already programmed. Open. So click on the reset. So it will start programming if you click on the reset. So to execute the program, so we must click on the reset. If you see, after clicking on the reset, the LCD started testing. So where it was displaying all the characters on the LCD, like the special characters, digits, and capital letters, numbers, small letters. So this helps us to verify that all LCD segments are working correctly, where the cursor movements is happening properly. So where the characters are displayed clearly without missing segments. If everything is displayed properly, it confirms that LCD is functioning correctly. So now let's go to the testing of 7-segment display, where it was seen displaying the hexadecimal numbers. So 1, 2, 3, 4 to 9, A, B, C, D, E, F. Now press on the RB1. After pressing on the RB1, the LED test will start. So you can see that all the LED one by one is displaying. See, LEDs are glowing on one by one. So this proves that LED are working properly, means LED connections are correct. Now testing of the buttons like switches RB1, RB2, RB3, the switches. Now click on one by one: RB2, RB3, RB4, RB5, RB5. It's okay. Now let's come to the serial communication test. So if you want to skip the serial communication, you can click on the RB1 so that it will skip the serial communication test. So by clicking on the RB1, we can skip this test. So let's see, click on RB1. So it will next go to the ADC, analog to digital converter. By moving the ports P1, so we can see the changes on the LCD display, like see 3 comma 4U, like that. So now let's move port 2. So see, by moving this also we can see some changes on the LCD. So let's move it. So see, you can see the difference. So after this we can check the temperature, like so by changing the temperature, after the temperature reaches the threshold threshold voltage, it will turn on the fan automatically. When the threshold temperature like exits, it will turn on, and when the temperature slowly decreases, it will turn off. So you can see that now. See, so temperature increased, it was crossed thermal temperature, I mean threshold temperature. Now the fan is running. See, so when its temperature coming down, means decreasing, we can see the fan will turn off slowly. So now from this I can conclude that the simulation verifies the complete functionality of the embedded systems, including LCD display, buzzer, 7-segment display, LEDs, push buttons, serial communication, but we skipped this ADC module. So through this project, I learned PIC microcontroller programming using MPLAB XID. So in that there is an inbuilt XC8 compiler. So which will be like it will automatically generate the hex file, and PIC SimLab simulator, which will be used. That X file is uploaded here, and we see the simulation here. So I understood GPIO interfacing, LCD programming, like how the LEDs and I mean switches, everything is connected to each other, and the real-time input-output control in embedded system. In this simulation, the complete embedded system was successfully tested and verified. All the peripherals such as 16 to 16 to 2 LCD, buzzer, 7-segment display, LEDs, as I said, everything was checked. After program loading and reset button is clicked, each components responded correctly, confirming proper hardware interfacing, port configuration, and software execution. The ADC, which is the analog to digital converter, accurately converted the analog voltage. When we moved the port 1 and port 2, you see the difference right in the LCD. So that was how it was changes. So into digital values. Proving reliable sensing and processing overall, this simulation demonstrate that embedded system is functioning currently and is ready for real-time hardware implementation. So uh, from so I really thank the Emertxe technology uh, members who made us to learn so many things by using the simulations, by not using the real-time hardware, but we used the simulation apps to know the things So thanking them. So we everyone thank you.